Get that full screen going. These are the graphs that go with lesson set 24. And yeah, I guess you can see everything there. So what I think I'll do is do I have enough light in here? Yeah, I guess so. What I think I'll do is I'll just do the graphs and then maybe talk briefly if there's anything to be said comes to mind. And that way, hopefully, if I just look at it and do the graphs, I won't make any careless errors late in the day here. I'm doing a lot of computations, so let's just have at it. I see a 1,5. So let's estimate 1,5 to be there, over 3 up 2, over 3 up 2, I'm about there, and I'll label that. Here I said I'd just do them and I'm talking. So therefore that's 4, and if I go from 5 up 2, it should be 4, 7. And please put arrows to show that this is a continuation. All right, if I make a mistake, I got backup. All right, V shape down. 8, 1, and let's go. I like always putting the y-intercept in there. So 8, 4, 2, minus 6 plus 1, minus 5, I believe is the case. And you can always put the numbers in to these calculations and see why I'm picking what I'm picking. Obviously, 16, negative 5 also. It should work. 8, 4, 2, minus 6 plus 1. Yeah. 8e to the x plus 3 plus 4. I make this a 3-to-1 ratio. So a lot of folks are not labeling the asymptotic behavior, and that's probably the most important part of the graph. So we've got a 3-to-1, so 0. So I want to make a 0, negative 3 does that. If I do that, I get 12. And then I like to get 6, so I'll put a 4 negative 1.9. Negative 1.9 plus 3. Yeah, my brain is tired. Is, I believe, 1.1, and 1.1 gives me 24 plus 4, 28. And there's your training wheels and your 3-to-1 ratio. Your first differential is 8. There's your first differential. I'm making my next one 3 times bigger because if you know e to the 1.1 is approximately 3, and if you know that e to the 0 is equal to 1, then you can make this 0 and this 1, 1.1, and get a quick graph. Square roots. If you're not sure what a square root function is, graph y equals the square root of x. Put the numbers in and find out. All right, so I've got one that's going down 5 times faster than the normal square root would go up. And so I got a 1, negative 3. There's the endpoint. X has to be greater than or equal to 1 is the domain. And the range is y values less than or equal to negative 3. Got to start saying that more often. I like the square root of 25, so I'm going to pick 26. 5, negative 25 minus 3 minus 28. Might as well do rise over square root of run. Rise from negative 3 to negative 28. I'm going down 25. The run is 1 to 26. I got to be careful what I say here now. 1 to 26 is 25, and I'm taking the square root of that. And lo and behold, negative 5. Rise over the square root of run. Or maybe I should say the square root of the change in x. I kind of like that better. All right, so log 0, log 1, log 0, undefined, so that's your asymptote. Whatever makes that 0, whatever makes 1, you're going to get the constant. And whenever I make log base 5 the same, I'm going to get 7 plus 3 is 10. So vertical asymptote, x equals 1. Inverse of growth. What makes a 1? 4. Could have also looked at go over 1. But 4, no, actually not in this case because of the 5. All right, so 4 gets me 3 without looking. You can check. And also 5, 15, 16 gets me 10, and you can check that out. Hope I'm right. If I'm wrong, somebody let me know. All right. Decay, asymptote, 3-to-1 ratio. So that's going to be 30 when I make this negative 1. So negative 5, 30 plus 3, 33. Check it out. And then this is going to be, well, I got to draw it. if that's there and I want a 1-to-3 ratio, I'm over here. That's 1-to-3 ratio. And so I'm going to throw a 0 in there and get a training wheel of 10. I'm going to throw a -5, get a training wheel of 30. And there's your 3-to-1 ratio. Well, 1-to-3. You always do the right-hand differential by the left if you're reading left to right. And so what did I say that was? I think I said it was a 0. And if I did that, 10 and 3, 13. Keep moving on. 7, I think there's 12 considerations here. We're halfway through. Sinusoid. Okay, I know the sine of 0 is 0. And I know the sine of 2 pi brings me back to 0, or where I start. And the sine function, I'm going to measure 0. And then when I start walking around the circumference of the circle, in the first 90 degrees, I go from the midline to the max. So I start at the midline. So let's make a midline. Let's make a max. Let's make a min. Let's get our range, which is 20 minus 11, which is 9. 20 plus 11, 31. That's your range. Y is less than or equal to 31, greater than or equal to 9. First 90 degrees up, then repeat. And that's when I start to repeat. So this is going to be 4. That's what makes a 0. That gives me 0. That gives me 20, the middle. All right. And what's going to make this at the end of the revolution go che? X minus 4. I want x minus 4 to mimic 2 pi. So it looks like 4 plus 2 pi. I didn't put a plus sign there. 4 plus 2 pi brings me back to 20. And then you got all kinds of symmetry. So you could show that as 4 plus pi gets you 20. 4 plus pi over 2 get you your max of 31. Let's do that one. Let's show that one because we're just learning this. Let's move this over. 11 sine 4 plus pi over 2. What happens to the 4s? They cancel. Where's pi over 2? It's right there. That's a maximum of 1 times 11 plus 20, 31. Helps to start to see how those numbers work. Another logarithm, another vertical asymptote when the parentheses equals 0. So x equals 3. E is not written, but 2.71 is a growth function. There's the inverse of growth. The inverse of decay looks like that. And you got to be careful with plus and minus signs here because that can flip the base. All right, so I want to get ln of 1 to get 10. So I see a 4 gets a 10. Let's call that 1 unit of change. And I like the ln of 6. I'm sorry, I like the ln of 3, which is approximately 1.1. I can make that happen. So this is roughly 3 times that distance. So that's a pretty decent graph. And a 6 is going to get me 17. Oh, no, I'm doing ln, excuse me. More time needed. 1.1 times 7, 7.7 plus 10, 17.7. Got to be careful. Cube root of x, that's the inverse of x cubed. The inverse of x cubed looks like this. Remember what x cubed looks like? What's the inverse of a little change in x, a lot of change in y? Big change in x, little change in y. So on and so forth. And so you put a couple of values in here. There's the origin. How about we put 8? 8 gets me 1. I hope you can see 27 gets you 3. 1 gets you 1. And negative numbers. So let's do -8. -8 gets me -3. A couple of arrows there would be nice. 3 more considerations. Cosine function. Well, cosine measures width. I always start over here, that's 0 distance on the circumference. Remember, whatever here is walking around the circumference. That's what this is about. I see the number 5, makes a 0. That means I'm there. Cosine measures width. 1 to -1. Widths go this way and that way. When I'm over here, I'm at a maximum width. Maximum width of 1. Back to 1. Let's get our range. 30 plus 7. 37. Midline. 30. Take 7 away. 23. Okay, so what makes a 0? 5. What do I get when I'm at 0 on the circumference? A maximum width, a maximum W of 1. So I'm at 37. That's why I'm there. Okay, 2 pi. When does this equal 2 pi? When does 2x minus 10 equal 2 pi? Well, let's add 10 to the other side. And then let's divide by 2. And I get 5 plus pi. So 5 plus pi. When I substitute 5 plus pi in here, you might as well see it work. Parentheses, 5 plus pi is getting multiplied times 2. So I'm going to get 10 plus 2 pi when I multiply it by 2. I didn't show everything, but hopefully you followed that lingo. All right, so 2x minus 10. And we got all kinds of symmetry here. So this could be 5 plus pi over 2. Now, if I double that, I get 10 plus pi. All right, so I'm starting at 5, but the 10s are going to cancel. I'm going to get, anyway, pi is half a rotation. And where's that? That's a minimum. That's why I'm getting -1. Take away 7, 23. Okay, getting tired here, so sorry for that awkward moment, but it is what it is. If you look at the numbers, that's how you're going to learn to graph anyway. Cup shape up. Okay, I know 0's on the decreasing side. I'm just going to shortcut this, so therefore I know that's 5 now. I don't have to worry about signs. 10 divided by 2. If I drop 5 in here, cut it in half, add 7, I got -93, and I can move on. All right, I asked for the sine of 2. The reason I'm asking these is it's really hard to learn what a radian is for most folks. So you got to realize that when you're doing the circumference of the circle, you're dealing with C equals 2 pi r. We're getting this thing called a unit circle where it doesn't matter the size of the circle, radius of 1. So that's a smaller radius of 1, but they bisect the circumference at the same place. And so if we start over here, we get an angle, which is represented as an arc length. And you can even think about it as that arc length because it doesn't matter the size of the circle. So I'm at 0. Frame of reference, 1.57, 3.14 radius lengths. And I'm going to keep saying that until I hear people go, oh, that's what it is. Where's 2? 2's closer to this. I'm somewhere in that vicinity. I know that's a height of 1. I know that's a height of 0. So what's that height? I don't know. I said on my answer key, approximately 0.85, just a ballpark figure. Now I can type this into Google. They have this thing. I don't know. They have this bar and you can type things in like the sine of 2 and it tells you what it is to a lot of decimal place accuracy. All right, that's the end of that video. That's the end of the midterm lesson sets. The second lesson set, we will develop more trig. It's a 311 class, folks. So we're not going to do a whole section on trig. We'll do that. See, lesson set 48 gets us probably at the end of the final. And so another 24 lesson sets after that, probably 10 lesson sets after that to get into some trig, into some serious trig, because we'll already have developed the foundation for the study. So we can tackle some more topics. And then probably a half a dozen, probably 40 Calc AB lesson sets. And probably pretty decent foundation if you overlearn the material. Set you up for hopefully higher levels. All right, so that's that. Off and running, stay safe, stay warm. And yes, if I made any mistakes, love the fact you're checking them because I don't have that much time anymore, despite the fact that I'm semi-retired. All right, be good, everybody.